Hello everyone. Good afternoon and good morning, and welcome to today's webinar titled It's Running Well, Surface Drainage 101, Linear Drainage Solutions with Modular Trench Drains, which is the first of our exciting two-part series on surface drainage. Presenting today are Dominic Turner from Armtech's Drainage Solutions Business Unit and guest speaker Jamie Kershaw from HAURATON. HAURATON is a global leader in surface drainage solutions. My name is Janine Yetke, and I'm the Director of Marketing for Armtech's Drainage Solutions Business Unit. My group runs Armtech's Drainage Solutions webinar program, and I'll be your host for today's event. We also have James Carter on the line, who is our technical moderator, and who will be running questions and answers at the end of the session. Before we move into the presentation, I'll quickly go over some housekeeping items. At any time during the presentation, if you have questions, you can enter them into the question log. We will answer questions at the end of the presentation, and we look forward to many. As a reminder, attending this session will qualify you for a 1-hour technical informal CPD credit. For those who have registered directly, we will send out the certificate to the email provided upon login. For those who are attending as a group, please compile your list of attendees and send the attendance list with the required details to webinar@armtech.com. I'd like to start off with a brief introduction to Armtech. We are one of Canada's largest infrastructure companies, supplying a full range of steel and HDPE-based bridge and culvert materials, as well as soil retention, stormwater management, custom engineered precast solutions, and standard precast products. Because of our convenient locations across the country, we are well positioned to serve you wherever your needs are. We serve numerous sectors, from the municipal to forestry, transportation, commercial, retail, and residential construction. More about how we service these sectors can be viewed on our website or through discussions with one of our experienced sales representatives. With our centralized engineering department and regional engineers, Armtech has the exceptional capability to fully support design and challenging engineered project requirements. It's always exciting to announce new product offerings, and we're proud to announce that through our partnership with HAURATON, a global leader in surface drainage solutions since 1956, we have added modular trench drain solutions to our product lineup. With HAURATON's long history and extensive experience in surface drainage solutions in over 60 countries around the world, their products are known for innovative design, and our sales representatives look forward to demonstrating how they can solve your specific project challenges. Presenting today are Dominic Turner of Armtech and guest speaker Jamie Kershaw from HAURATON, joining us from the UK. Dominic is Armtech's National Sales Engineer for HAURATON products. He is responsible for managing Armtech's portfolio of HAURATON surface drainage products. He has been with Armtech since 2013 and has experience with our full range of drainage solutions products. Jamie Kershaw is an international key account manager for HAURATON and has over 25 years of experience with the promotion and specification of surface drainage systems across a wide range of project types, including airports, ports, public spaces such as parks and town squares, commercial and residential properties, which you'll see today. Both of them look forward to plenty of questions and answers after this presentation. And with that, I will now hand off the presentation to Dominic. Welcome, Dominic.
Thank you, Janine. So everyone should be able to see my screen right now. So welcome everyone to our webinar. Thanks for joining. Today's webinar will be an introduction to surface drainage with modular trench drain. And then we will present a second webinar, which is Surface Drainage 201, on March 18. So this one will be a little bit more technical. So I know it's Friday today, and I promise the content of this webinar will be not too complex. So let's start with the agenda. I propose today to talk about comparison between traditional point drainage and linear drainage. Then we'll talk about of course, the benefits of linear drainage. Then we'll cover the nomenclature and features of the modular trench drains, including configurations, outlet options, and also the international manufacturing standard that is specific to trench drain, which is EN 1433-2002. Then I will end off the presentation to our guest speaker, Jamie, for the very interesting pictures of several project applications and two very interesting case studies so you can actually see how we use those trench drain in specific projects. So let's start. There are two methods of drainage of impervious surfaces. The first one is traditional point drainage. So point drainage water is intercepted at low points and then will be catched through catch basins. So the catch basins are basically connected to an underground storm sewer, as you can see on the top corner picture. And this type of drainage is really useful for the drainage of the areas with steep gradients. You can think of roads where you have catch basins installed against the curb. So that's the perfect application for point drainage. And often it can be used in conjunction with linear drainage system. So on the same project, you could have both point drainage at some point in the project and then having this combined to a linear drainage system as well. Point drainage can present some potential issues, mainly, well, costly. It's costly because there are many structures, so you can think of all the manholes, the pipes. The grading also is complex because you have all those reverse pyramid shapes to be constructed. Installation time is longer as well because you have deep excavation and a lot of structure as well. Then it creates, of course, an uneven surface, which is less comfortable for our users, and also less aesthetical, mainly with pavers. You can think of an undulating surface with pavers. It just looks uneven, right? And then, of course, that type of system is also difficult to access. Not difficult, but it involves extra cost because of the extra structures as well as the underground structures. It can be, in some cases, creates inefficient performance, which leads to pounding and blockage that you can experience with the aging of the pavement. Also deeper inverts that may enter in conflict with underground services. Now linear drainage is a different story. Water is intercepted along the entire trench drain run. So the interception rate is far greater due to the larger grade area. Very useful, well, it's cost effective because it involves less pipe work, structures, and so on. Also, it suits really best for a large impervious surface, especially level surface. So with no ground slope or maybe a small ground slope. Also, you can think of using it as a cutoff drain. You can think of an entrance of an underground parking where you have this steep slope. So at the bottom of the ramp, you would have that cutoff drain. That could be, well, linear drainage would be perfect for that application. That being said, let's talk about the benefits. So it's more efficient at intercepting runoff water compared to point drainage because the grade area is basically the length of the trench drain times the trench drain width. So this surface is going to be way larger than if you add all the catch basin grade for the same drainage area. Pounding is also reduced or eliminated even with the aging of the pavement, after which you can be sure that the water will still likely to find its way up to the linear drainage system. Then shallow depth of construction, so everything is on the surface or almost, so there is no deep excavation to be done. Also easier grading because you don't have any reverse pyramid shapes or low point to be constructed. Just only one or two slopes in the drainage area and you're fine. More economical because fewer manholes, less pipe, faster installation as well. Easy access along the entire length of the linear drainage system, so it's a surface work. And then eliminates the roller coaster effect for vehicular traffic that you may experience with point drainage because of the undulating surface. And last but not least, very aesthetic solution that can be easily integrated in a very elegant manner with your projects. And I'll let Jamie show some pictures, some really nice pictures in the project application section. In the next few slides, I'll be covering the nomenclature and features of the trench drains, just to make sure we know which are the correct terms to use. On this exploded view, you can see two modular trench drain units that are an assembly of a channel and a grate. And it's usually 1 meter long, but it can also be supplied in half a meter long, especially if you want to do a curved design of the trench drain. Then followed by a catch basin, which is 0.5 meter long. This particular system is for civil works application. As you can see, there are 8 boats per meter securing the grate on the system, and many accessories are available, like the end caps outlet with or without outlet. Now this system is a trench drain designed for a landscaping application, really similar to the other one, but this one is especially designed for traffic, to be trafficked by pedestrians, bicycles, and small vehicles. So the main difference is on the locking system, well, the system to secure the grate on the channel. So in that case, we're talking about a locking bar. So there's one boat retaining one grate, which is half a meter usually. Now there are several dimensions involved in trench drain system. So on that picture, number 1 would be the grate width. Number 2 is the overall width of the trench drain. 3 is the clear opening, and that's an important dimension because this is directly connected to the capacity of the trench drain because it's the inside dimension. Same thing with the number 4, invert depth. So those dimensions should be basically the one we use for specifying trench drain. 5 is the overall depth of the trench drain. Now let's talk about the features of the trench drain. This is very general information about modular trench drain that are available on the market. So it comes in variety of width. Most systems will have a clear opening of 100, 150, 200, or 300 millimeters. Some systems can have a larger clear opening, 400 millimeters, and even more. Channels are usually 1 meter long, can also be half a meter long version. Material, basically usually it's either composite, fiber reinforced concrete, or polymer concrete. There are also less common material as steel and cast iron, but mainly those are the one we commonly see on the market. There are 2 types of invert, pre-slope and neutral, but we'll talk about more in depth later on during the presentation. There are several various design grades that are available: mesh, slotted, perforated, longitudinal, decorative. That can be done of multiple material, galvanized steel, stainless steel, ductile iron, or composite. Usually they are 500 millimeter long, but they can be also provided in 1 meter long. Basically, modular trench drain are delivered assembled, so the channel with the grate secured on it. Now, Armtech product line is a Recific product line by HAURATON. All the channel in this product line are made of composite, and more fully of polypropylene. The grade material really depends on the application type, but it can be either polyamide, galvanized steel, ductile iron, or stainless steel. And depending on the choice of the grade, we can cover all the load class application from A15 to F900. I'll come back to that concept, but this referred to the application regarding the load applied to the trench drain. Now, all products complies with the International Manufacturing Standard for Trench Drain, which is EN 1433-2002. All those products are extremely lightweight compared to concrete products available, other products in concrete, which result, of course, in a fast installation and safer handling. The torsion-resistant ribs that you can see on the channel, well, they are very important with composite trench drain because it ensures a proper anchoring to concrete, the cast-in-place encasement, that prevents channel from being pulled away from concrete during freeze and test cycles. The composite construction provides high chemical resistance and very high impact resistance as well. So the product is not brittle. You can drop it and you can make sure that it'll be just fine, which is not the case with other material products. It's also very durable. It has been installed across the globe for the past 20 years, with several of them exposed to very difficult conditions like frost, de-icing salt, and UV radiation as well. It's also 100% recyclable. Now let's talk about the configuration of the trench drain. So I said there are two types of trench drains available. So that's neutral invert and pre-slope. So the neutral invert it's a trench drain run that is composed of units having the same depth and width interconnected together, as you can see on the picture on the top. So there's no slope within the channel. The pre-slope system, on the other end, is composed of units with inbuilt slope at the bottom of the channel. Each unit will have a different and variable depth. Generally, a series composed of a series of 10 or 20 different units, 1 meter long, which will create an inbuilt slope of either 0.5 or 0.6%, depending on the model and the manufacturer. But I want to tell you the hydraulic gain with pre-slope compared to neutral invert is minimal. If the capacity, for example, if the capacity of a neutral invert would be insufficient, there's a big chance that its pre-slope counterpart will be undersized as well, because really the hydraulic benefit is minimal. On the other hand, choosing a wider trench drain will have a huge impact on hydraulic capacity. And by the way, Armtec can provide hydraulic analysis of trench drain capacity according to the project design parameters. So neutral invert, as I said before, they are composed of constant depth units that are very easy to install compared to pre-slope because it's just laying out on a level foundation. All trench drain units are identical, so interchangeable as well, and gravity naturally forces water towards the outlet. Usually, a preformed slope is not required to achieve an efficient flow. A better alternative to pre-slope system, in our opinion, is the step-fall layout. So basically, we use constant depth unit that will have a series of constant depth unit of different depth interconnected together with step connectors, as shown on the picture, on the right picture. The result flow will be similar to a weir configuration where water is confined in a channel with falls, improving the velocity of the flow. So a step-fall layout, again, constant depth trench drain sections. It's in fact series of deeper trench drain units that are interconnected, which creates an installed gradient within the trench drain run. So positive water flow towards the outlet. And we prefer step fall configuration over pre-slope because installation is easier. You just have basically, you need a level foundation with steps. And moreover, the sections are interchangeable on the field. So if you damage a part for some reason, then it can be replaced with another unit, and then installation can continue, which is not the case with a pre-slope system. Surface gradient. So the most common situation is the zero ground slope, so the level ground slope, sorry. Either a constant depth or step fall works great. However, maybe the step fall help achieve better flow in longer trench drain run by maintaining the flow velocity. But again, the benefit is minimal. The main benefit would be to reduce the size of the unit upstream. Then the ideal situation is the positive ground slope. So both configuration, again, works well, but constant depth unit will be easier to install. Now let's talk about the outlet options. So every trench drain needs to be connected to an underground pipe system or outfall at some point. There are various options regarding the location, the size, the type, and the type of outlet. That will mainly depend on the trench drain width and also the site conditions. Outlet is critical because this will influence the discharge of water within the trench drain. So an undersized outlet may cause a proper trench drain size to overflow. So keep that in mind. Outlet shall be installed with a minimum of 1% slope. This is to ensure a proper discharge and also prevent ice clogging during the cold season. Now the outlet location, type, and size, well, the major factors, first one is the location of the main carrier pipe, because let's take, for example, a storm sewer that would be parallel to the linear drain system, then the trench drain can be reduced in size with the use of multiple outlets. But the site and design parameters have the major influence. So these are drainage area size, runoff coefficient, site levels and gradients, design rainfall event, type of trench drain system, capacity of the trench drain, and also the conditions that are specific to the construction site. The outlet location. Well, I remind you, one of the good benefit of linear drainage is reducing the pipe work and the associated structures. So the idea when locating the outlet is to reduce the pipe work, which will means time and cost savings. So the most common configuration is the end outlet. It involves, of course, longer trench drain runs, and the units will carries more water, so we need larger unit. The central outlet is the most effective one when possible, but it really depends on the location of the storm sewer. Shorter, well, the trench drain run will be shorter, which leads to smaller trench drain units. Double end outlets is ideal when the ground level is highest in the center of the drainage area, right here. And this it depends on the pipe location, but it may suit this layout as well. But in the case of a ground that is level, we would recommend to use step fall configuration. The outlet types. So remember, the outlet is critical because directly related to the discharge of the trench drain. So the first option is the end cap outlet, which is an horizontal outlet at the end of the trench drain. There is also the side outlet that is a little bit less efficient than the end outlet because of the changing of direction of the flow. A better solution, which with a huge improvement in the hydraulic capacity, is a vertical outlet, so a connection at the bottom of the trench drain. But the best option is the modular catch basin, because well, the invert of the outlet will be deeper, which leads to a higher head pressure and also an optimal flow. Plus, the catch basin has a sump for sediment settlement. Another option that is not shown on the slide right now is a cast-in-place or a precast manhole that is also very, very efficient on the hydraulic standpoint. Now let's talk about the manufacturing standard of trench drain. So this standard, again, is EN 1433-2002. This standard is called Drainage Channels for Vehicular and Pedestrian Areas. In this standard covers definitions of the terms, classification, which is load class, I'll come back to this later, materials, dimensions and tolerances, marking, testing, and the evaluation of conformity of the trench drains. So we'll cover a few of them, the most important one. So first of all, there are two types of trench drain. The first one is type I, which is a self-supporting one. That means it doesn't need any concrete encasement to be poured on site. This is mainly reinforced concrete products made to measure, but those represent a small percentage of the market, mainly because of the high price. On the other hand, the type M requires a concrete hunch to support it, with minimum dimensions X, Y, Z. That will depend mainly on the load class and the application of the project. Now the material. The channels can be made either of cast iron, steel, stainless steel, composite, fiber reinforced concrete, polymer concrete, or reinforced concrete. The main one are composite, fiber reinforced concrete, and polymer concrete, which is not a concrete, by the way. It's rather a sand and polymer mixture because there is no cement in it. Now let's talk about the load classes. So this is very similar to the live load we know, but this is specific to trench drain. So the number next to the letter, let's take A15 for example. Well, the 15 represent the proof load that is applied to the trench drain assembly, so the channel with the grate secured on top of it. So it would be 15 kilonewton in that case. So on the left side of the screen, you have the light duty to medium duty load class. So that's A15, residential areas used by pedestrian and cyclists, B125 for sidewalks, pedestrian areas, and residential parkings. Then you have C250 for parking lots in general commercial areas. Now on the right side of the slide, we have the heavy duty to extra heavy duty applications. So we start with D400, which is suitable for roads, highways, and other areas. E600, which is specific to industrial areas, usually used by hard tire forklift and heavy vehicle. So you can think of a port and a dock. F900, special areas with very heavy wheel loads. So that's mainly airports. Now, since I'm sure a lot of you just learned about the trench drain load classes, we have prepared a comparison chart between D400 load class and some North American standard we use for, well, cast iron covers and grates. So depending on the trench drain width, the proof pressure of the D400 load class will be between 8,000 kPa and 21,000 kPa. So let's take for comparison the smallest pressure, which is the one for the largest trench drain, the one over 300 millimeter, which is 8,000 kPa. So if we compare that to the B&Q standard for cast iron grates and covers that is used in Quebec, then it's about 2/3 of the pressure used with the D400 load class. Now, if we compare AASHTO M306, which is used in other Canadian provinces and as well across the US, then the proof pressure for the HS25 live load is about half of the D400 load class. Then just for your record, there is CH-BDC CL625 and CL800, just to give a comparison. It is about a quarter of the D400. But remember, this is just to get a big picture, because the load class is the only standard that applies to trench drain. All the other one doesn't apply to trench drains. So I'm done with the technical material, so I will now hand off this presentation to Jamie with the very interesting project applications. Welcome, Jamie.
Hi, Dominic. Hi, Dominic. Thank you for a very detailed introduction to trench drainage. Good day to all. Thanks for your time and interest. We really appreciate it. My name is Jamie Kershaw. I'm HAURATON's representative today. I'll now proceed with covering project applications, followed by 2 case studies, which we hope you will find interesting. Generally, surface drainage by modular trench drains should be safe, durable, cost-effective, that's in relation to installation and long-term maintenance, maintenance-friendly and aesthetic. Modular trench drain systems, they generally provide efficient drainage of external hard surface areas, and for virtually all project applications, the Resifix systems provided by Armtec have been designed for surface drainage in external areas. In terms of project requirements, you may find that you need to use a variety of different systems on the same project. As an example, we have a supermarket, and here you see on the left-hand side pedestrian access. So you need a system that can take pedestrian loads, maybe an aesthetic system. In the centre, you see a parking lot, maybe with a wider grate, intake capacity a bit greater. And then on the right-hand side, you see a service yard with heavy-duty systems. So on the same project, you have different systems for different requirements. Here you see Toronto Pearson International Airport. Airports are small cities. In the airside areas, you generally have heavy-duty systems. And again, there are different areas, hard stand areas, de-icing platforms. De-icing platforms, you may need corrosion-resistant systems, high-capacity systems. Again, fuel farms, corrosion-resistant systems. So there are different types of application, and you may need different systems for that as well. And then landside, a series of different applications, and again, different systems to suit these applications. So here you see airside areas with a slot drain system and also a grated system. And then landside areas, you have hangar areas internally and externally, and also surface drainage for outside of terminal buildings. Ports are very similar to airports in terms of they have in the quayside areas heavy-duty requirements. Here you can see a slot drain system and a grated system again, and again a wide range of different applications and different requirements. And you see there many different applications where modular trench drain systems will be used. Loading docks, again, an area where modular trench drain systems are used. You see here where you see the tyre of the heavy goods vehicle. The benefit of the slot drain system here is that the tyre rests on the concrete surround and not on the channel, and the load of the tyre is imposed through the concrete into the foundation. So again, this is a very effective system for these heavy-duty areas. Warehouse and distribution facilities, grated systems are often used in these areas, and here you see E600 kilonewton system. They can withstand the forklift tyres, solid tyres, heavy vehicles. So obviously grated systems are also used in these sorts of applications. Highways, roads and streets. Here you see the drainage is moved away from the traffic flow adjacent to the curb line or it's protected by barriers and central reservations. So obviously it's not sensible to have the drainage system in the area where you have the main traffic flow. Rail and light rail, other applications for modular trench drain systems. You see the photograph on the left-hand side, you see a typical platform area, and you see there's a slope from the edge of the platform internally, and that's for safety reasons, so that if there are any prams or wheelchairs, obviously it's safe for the occupants. And so generally they have a modular trench drain system in that type of location, and these are generally shallower systems. And Armtec can also provide a fully composite system which is not non-conducting. So again, if you have live wires, rail wires, you don't want a system that's, that can conduct electricity. So that's for safety. Public buildings, heel-safe grates, decorative grates. Safety in schools, for example, these systems are used a lot in school playgrounds and other public buildings. And obviously, it's important to have safe systems for our children. Facades and commercial buildings. Generally, when you have rainfall, if you have a large building, the rain will hit the side of the building, and you have a large volume of water running down the side of the building. So these systems are used to gather that water and channel it away effectively, and it prevents water ingress into the foundation. And entrances, obviously, you want to prevent water from being walked into the building or actually flowing into the building through surface flow. So often a positive modular drainage system is used in these locations as well. And you see on the right-hand side, the trench drain system can be quite aesthetic and decorative. Multi-level and basement parking areas. Multi-level parking, you've got shallow drain systems, generally installed above the damp-proof membrane, and then ramps, you have grates that have got high intake capacity, because if you have a steep ramp with water flowing down, you want the water to be gathered very, very effectively and quickly. And shopping centres, you see here you have a linear drainage system, a discrete slot drain system. These are becoming very popular for these areas, very contemporary. They match very well with the modern street scene design. Very discreet, very aesthetic, and in some designs they're used to demarc one type of surface finish from another type of surface finish, so they can be used as a design feature as well. And residential areas, again, commonly these systems are used in residential areas. Here you see garage, a trench drain system across a garage doorway. Right, first case study. This is a project that we supplied to a company in Switzerland. It was a building materials distributor. The project was in 2013, so about 2 or 3 years old, and it was an outdoor storage area. And the factors for this project were the requirement for a new trench drain system at the base of a ramp. So it was being used as a cut-off drain to gather sheet flow of surface water down the ramp. Heavy duty loads, there was a lot of forklift traffic and heavy vehicles running around. Forklift traffic with solid and pneumatic tyres. So you had varied traffic pattern with speed, angle of running over the system, turning on the grate, braking on the grate, static loads. So you had very big, high dynamic forces and impact forces, and a lot of stress on the system. Also, Switzerland is very similar to Canada in certain ways, in terms of extreme temperatures, because the temperatures can vary between -5 degrees centigrade to +30 degrees centigrade. Maybe not as extreme as Canada, but if you actually get to the higher areas in the Alps, it can get very cold, and materials can be subjected to frost attack. Strong UV radiation. It's very clean environment in Switzerland, so you get very strong UV radiation. And also in this area you have fuels and oils as well. So the system requirements were high capacity trench drain, hydraulically efficient, high intake capacity with efficient interception, obviously high loading requirements, a system that's safe and reliable, resistant to dynamic and impact forces, temperature and frost resistant, UV stable, quick and easy to install, simple to maintain, with low long-term maintenance costs. And the system that we suggested and supplied for this project was the Resifix NC trench drain system. It's on this particular project we supplied a 200mm wide trench drain unit. The dimension is the measurement across the inside of the system. The body is manufactured from composite polypropylene. That has a carbon content greater than 2%, so it's very UV stable, and that's the requirement for the standard DIN 19580 and also EN 1433 as well. Modular units were 1 metre long, and here you can see how light they are, 20.8 kilos, so very, very light units. And the loading was E600, so it's a heavy duty load. The grate was spheroidal ductile iron, slotted grating, and that's the grade that we supply is equivalent to ASTM 705005. So it's a high grade of ductile iron, and the slot width was 18mm, so again great intake capacity. As Dominic mentioned, this system has a grate with 8 bolts per metre, 4 bolts per half metre grate, and these are fixed into the edge frames for a very durable system. And here you can see the trench drain installed, and the forklift, solid type forklift running in all different directions with heavy loads. And the client was very, very satisfied. 2 years after the installation, there was no sign of wear or tear. The channel was performing very well, so that's one satisfied client. So thumbs up to the Resifix NC system. Now the next case study is a little bit larger to show you the diversity of what Armtec can provide. This was a military air base in the United Arab Emirates. The client was Command of Military Works, consultant CH2M Hill, design and build basis for the contractor, and again 2013, so it was 2 years old, 2 or 3 years old in terms of the implementation, and this was a facility for the UAE Army, Navy and Police Forces. And here you can see the airfield extension where the channel system was installed. Now initially CH2M Hill specified a concrete trench drain system for the area, and we, through our hydraulic design system, we proved that the specified channel didn't have the sufficient capacity. Another concern for the client was the environment, because the environment in the Middle East is very, very corrosive. You have a mixture of high humidity, saline conditions, windborne sand that sandblasts materials, high temperatures, ground sulfates. That cocktail is very, very aggressive. So we proposed the Resifix High Cap F slot drain system, which is a high capacity slot drain system. The factors, the requirements on this project were for a new surface drainage system in concrete pavement areas, an extensive catchment area, ultra heavy duty loads, frequent traffic and a varied traffic pattern again, with variety of high speeds, variety of angles of trafficking the system, turning and braking and static loads. The environment, as I mentioned, was very corrosive, and the temperatures 36 degrees C and above, it can get up to 50 degrees centigrade. So in these areas, very, very high temperatures as well, and at night time. So again, you have quite a wide diurnal varied temperatures. Obviously strong UV radiation as well. And something similar to Canada again is the rainfall intensities. When it rains in the Middle East, it doesn't rain that often, but when it rains very, very heavily. So typically projects can be designed using rainfall intensities between 100 to 150 millimeters per hour, which I believe is similar to Canada as well. Again, system requirements, high capacity trench drain for this project because there was a large extensive area, high intake capacity, efficient interception for the system, high load capability, safe and reliable, resistant to dynamic and impact forces because obviously heavy duty aircraft and vehicles, UV stable, quick and easy installation. So the system we proposed for this project was the Resfix high cap slot drain system. It's an F900 system. Those are the three sizes that were supplied onto the project: 200, 300 and 680. And you see the big 680 trench drain or slot drain system, that's only 30.6 kilos, so even the big units are very, very light. There's over 1,800 meters of channel required. These were 1 meter units. The 680 is 1.14 meters long. Polypropylene composite body, again UV stable with carbon black added. F900 loading, and the grate was a ductile iron grate. We supply these grates with a KTL cathodic dip coating, which is a special coating that we supply standard with this unit, which is very good for this area because it's again corrosion resistant. And the slot width is 28 millimeters. Now, some people may feel that these systems have, with a very narrow slot, the intake capacity may be reduced, but that's not the case. A 28 millimeter wide slot on this system will cope with 13.5 litres per second per metre, which is equivalent to about 972 millimetres per hour, and that's rainfall falling in an area of about 5,000 square metres. So you don't get any 972 millimetres per hour. That is rainfall that you will get. That in Canada, you'll not experience that type of rainfall nowhere else in the world. So this system can cope with any rainfall anywhere in the world. Here you see an exploded view of the system, and then on the right hand side you see the system typically installed in concrete. We provided a design proposal. CH2ML issued drawings of site layouts, drainage layouts, runoff coefficient, rainfall intensity rate. On this project it was 45 millimeters an hour because the client wasn't too bothered about how long water. It wasn't a huge requirement to take water as quick off the surface in the areas where the drain was located. And we also provided temperature resistance, jet blast resistance and material resistance information as well, because it's obviously a critical area. Site preparation, here you see the big high cap slot drain units, the 680 units, ready for installation, and the trench is being prepared. Armtec can provide modular catch basins for the smaller units, and on this site we had the units locally made, large catch basins locally made, and the connection unit to the channel, to the high cap channel, was actually cast into the concrete chamber. And here you see the channels installed in the trench, and here you see rebar being fitted to the channels after being installed in the trench. And finally, the surface finish being applied, and obviously there's a throat protection strip as well to prevent any ingress into the system. And then the final installation, here you see, obviously you can see that it's a very extensive area, so they need a high capacity trench drain system for this area. And again, another view of the installation. And the thumbs up here, the client feedback, probably the best feedback you can get. The clients then went on to use this system on 2 additional air bases. So that's probably the best. Thank you very much. That's my part done, and we look forward to questions at the end of the session.
Thank you, Dominic and Jamie, and thank you everyone for joining today's webinar. We hope you enjoyed the presentation. Before we jump into our Q&A session, I'll quickly review a few housekeeping items. Please stay tuned for a Q&A session in just a minute. As you saw in the presentation, there are a lot of technical considerations for surface drainage design, so when the need arises, Armtech can help support you through the selection and design process. Feel free to contact us at any time. Dominic's contact information is shown on the screen, and he can help answer your questions or connect you with a local representative near your project location. Today's presentation was the first of our 2016 webinar series and the first of a two-part series focusing on surface drainage solutions. We hope you enjoyed it, and we look forward to you joining us for the exciting follow-up on March 18th. Material covered in the second part of the series will include a step-by-step process for selecting the right modular trench drain system for a project, so sign up for the webinar to learn more. To stay informed, please stay connected with us. You can follow us on social media on Facebook, LinkedIn, and if you know someone who was unable to make it to today's webinar, it will be posted in the near future on YouTube, as are all of our past webinars. You can also get the latest on Armtech by following us on our website, armtech.com. We really do value your feedback, and at the end of the webinar, there will be a quick exit survey, so please let us know what you think of this event. Question 6 will ask if you're interested in receiving more invitations for Armtech webinar events. Please select yes, please. Due to strict Canadian anti-spam legislation, we are required to have your consent to receive future invitations. So to ensure that you're on our invite mailing list, please choose yes on our exit survey. Thanks again for joining today. Again, to ask questions, please enter your question into the question log on the GoToWebinar interface. Feel free to ask anything you'd like, and if we can't get to everything during the time period, we will reply and get back to you at a later date.
So we got quite a few questions here. Please keep them coming, and as Janine said, we'll anything we don't get to, we'll make sure we follow up with you directly. First question, there was a question about freezing issues or cold weather applications with a lower depth of bury.
Okay, that's interesting. Yeah. Well, first of all, those systems have been installed over 60 countries, so experience have shown that it works really great, especially the Recifix systems, well, that have been installed a lot in Russia, which is a weather that is very similar to Canada. And well, polypropylene can, of course, withstand a large span of temperature, as low as less than minus 30 degrees without any problems. So for a very low temperature, which would be the case northern in Canada, then we would recommend to have a complete concrete encasement that is to the top surface. But usually for the more urbanized city in Canada, it's not necessarily necessary, depending on the on the application and the load that will be applied to the trench drain. We have to keep in mind that the concrete encasement, we will need to have some crack joint to make sure that there is an expansion that is possible for the concrete encasement. I don't know if Jamie, you have something to add on that question.
Yeah, in terms of the low temperatures that the material can withstand, the material can withstand temperatures down as low as 30 degrees, minus 30 degrees Celsius, and even lower than that. Dominic was correct in saying that when you get down even lower than minus 30, it's sensible to install the system in concrete, with the concrete encasement going to the top surface, and that provides concrete provides a little bit of it actually insulates the trench drain system. And also, I think in terms of snow and ice and these systems, what you tend to find is these trench drain systems are used in pavement areas, and the pavement areas are generally during winter months are generally kept. You know, they use de-icing salts and de-icing solutions to keep the pavements clean and safe. So that will also help keep the trench drain systems clean and clear of ice and snow. And another point to note is that these material, polypropylene, is actually resistant to salts as well. So it's a material that can be used in this environment and it won't corrode. And Armtec will also provide composite grates as well. So again, you've got a system that is totally resistant to the environment, and there's obviously a lot of de-icing salts and solutions that are used, and it's resistant to that as well. So the system will be kept clear with the help of de-icing solutions, and it's corrosion resistant as well.
Another question, as the grading holes are smaller than traditional catch basins, do they block more easily with leaves, etc.?
No, actually we provide different type of grates depending on the application. It can be wider or smaller slot, but honestly it's not a problem because it's not comparable to a catch basin, because the catch basin is a really it's a constrained area. The surface is not that large compared to a linear drainage system like the trench drain we propose, because you have a continuous grate. So the intake rate is not an issue. Now, depending on the site conditions, if it can be a concern depending on the sediments or the type of, if there's any branch that can enter in the systems, then we can adapt the grate to put on the system, so we choose something that is appropriate to the site condition.
Yeah, that's a good question. I mean, one thing I would say is, Dominic mentioned this earlier on in the presentation, obviously point drainage has small grates in certain areas, and with linear drainage, the actual intake surface area is much increased. So you have the actual intake area is a lot greater. So that obviously helps ensure that the drainage is not impeded off the surface. Another point to note as well is we do have, Dominic is correct, we have different types of grates for different environments. We have in areas where you have pedestrians, we have heel-safe grates with narrower slots, and actually the narrower slot is a benefit, because what it does is it stops the material and the debris from actually entering into the body of the channel. So in a way, if you have grates with narrow slots, it can be a benefit because it helps with reducing the maintenance requirement. And in certain areas, for example, in the US, they have the ADA regulations in terms of the disabilities regulations, where they call for narrower slots as well. So we can, some of our systems and grates comply with that. But it's not an issue. We've never found an issue that the system doesn't function well because the slots are blocked. And obviously these systems are maintained regularly, and again, it's from a maintenance point of view, they're easy to maintain and easy to keep clean as well. So it's certainly not a problem, and it never has caused a problem with the size of the slots, causing blockage.
That's great. That's an interesting clarification to make, that you have so much more area covered that you're not likely to get a large pooling or blockage with the leaves. There's a question here. What is the maximum length of linear drainage, or is there one?
Well, yeah, that's a very good question. In fact, it really depends on the design parameters, because there's no it's not limited, but the problem is depending on the location and the number of outlets, and also the design parameters. So what's the rainfall intensity we're looking at, then the system might overflow if the outlets are not properly installed. So that's the only limitation you get, because the system can be very, very long. We can provide systems that are more than a kilometer long without any issue. So it is really related to the design parameters and how much, well, the configuration of the outlet, because as I said before in my presentation, this is the critical part. This is what that is directly related to the discharge of the trench drain system, actually.
Yeah, and I'll add to that, Dominic, if I may.
Sure.
again, Dominic's dead right in terms of it depends on the project requirements. Just to give you an example, the high cap system, we have 6 different channel sizes in the high cap range, and we can configure this in a stepfold configuration. The largest channel is 680 millimeters wide, and the overall height of that is 1,170 millimeters. So what you can do is you can have a very long trench drain run, and you can include the 6 different channel sizes. So potentially you could go up to 200, 250 meters before an outlet. So that's one of the big advantages of the high cap system. And then we have other trench drain systems as well, which have different depths. So all of our trench drain systems have a variety of different depths. So if you have a requirement for longer channel runs, what we can do is we can include deeper units and have a stepfold configuration. So we can do, obviously longer trench drain runs again. But it's generally what we do is we look at the project, we look at the catchment area, the rainfall intensity, we look at the runoff coefficient. So we look at various criteria with regard to each project, and then we can size the channel according to the requirements of the project, and we can also give you advice as to whether you need step fall or depending on the length of the channel run. So these systems are very, very flexible, and they can allow you to drain very, very long trench drain runs.
There's a good question here about maintenance. Are there issues with removing bolts after a couple of years of use in order to lift the grates out and clean the system? I guess the concern might be corrosion or something.
If there is an issue with, if there's a concern with regard to corrosion, for example, if you're, if you have an area where it's going to be, there's going to be de-icing salts and solutions around, what we can do is we can provide locking bolts and bars in stainless steel, or we can provide them in composite materials as well. So we have the option of composite materials or stainless steel. So we can tailor the design of the product to suit the requirements of the project. And we've never had an issue with the client or the maintenance team of a local authority not being able to open the systems. Because obviously what we do is we listen to the consultants and the client at the design stage, and we then provide, we obviously ask all the right questions, and we provide the system that suits the requirements of the project. So if there is an issue of or a concern with regard to corrosion, then we can provide a corrosion-resistant product.
This is an interesting question. Can the system be used specifically to reduce peak loads on the existing stormwater collection system? You reduce overflow events?
If I interpret that correctly, I'm assuming that might mean whether the system can be used as an attenuation system to help control the flow of water away from an area, and certainly the high capacity channel systems, trench drain systems like the high cap again. Obviously the largest high cap unit is 680 millimeters wide, and what you can do is that system can be used as an attenuation system to hold water on the site in order to control the flow of water away from the site and meet certain discharge requirements. So for example, what you can do is you can have flow restrictors actually installed at either the end of the trench drain run or midpoint intervals along the trench drain run. You can have flow restrictors installed, and that will help control the flow of water away from the site. So what we do is we look at the design slightly differently in that respect, where the system is used as a containment or an attenuation system. So we design it a little bit differently. Generally, the same size of channel is used, the same size of trench drain, so that you have maximum storage. So it can be used. These systems can be used for local attenuation in areas to help obviously control the flow of water off the site.
Thanks all for attending. Have a wonderful afternoon and weekend, depending on where you are, and we'll see you again on March 18th.
Thank you very much.
Thank you, everyone.
Yeah, thank you.